Welcome to Next Level, gentlemen. I'm your host, Callum Wren, and today we're diving into a field that impacts nearly every decision we make, often without us even realizing it: statistics and probability. These mathematical concepts shape our understanding of chance, data, and the patterns that help us make sense of the unpredictable world around us. From understanding trends in our daily lives to interpreting complex scientific data, statistics and probability are fundamental in helping us navigate information and make informed choices. So, what exactly are statistics and probability, and why are they so crucial? Let's start with statistics. Statistics is the science of collecting, analyzing, and interpreting data. It allows us to identify trends, draw insights, and make decisions in areas like business, sports, healthcare, and beyond. In fact, many decisions made in fields as diverse as medical research, public policy, and environmental science rely heavily on statistical data. Meanwhile, probability is the study of the likelihood of events happening. Though it's often associated with gambling, probability plays a much bigger role in assessing risk and understanding uncertainty in everything from weather forecasts to financial investments. Together, statistics and probability provide us with powerful tools for measuring, predicting, and interpreting the world around us. Let's start by exploring some foundational concepts in statistics. A key part of statistical analysis is something called central tendency, which includes the mean, median, and mode. These terms might sound familiar from high school math, but they're incredibly valuable in real-world applications. The mean, or average, gives us a central value, offering a snapshot of where most data points lie within a data set. For example, calculating the average salary within a company can reveal income disparities or general trends in employee pay. However, while the mean provides a broad overview, it can be skewed by extreme values, like unusually high or low salaries, which can distort the picture. This is where the median comes in. The median helps by identifying the middle value of a data set, which can give a clearer picture in cases where data might be skewed. Unlike the mean, the median isn't influenced by extreme values, so it offers a more stable view. And then there's the mode, which is the most frequently occurring value in a data set. It can reveal patterns, such as common scores on an exam or popular choices in a survey. By using these three measures, mean, median, and mode, we can get a much more complete view of a data set, uncovering deeper insights beyond just the average. Central tendency indicates where values cluster, but to fully understand the data, we also need to measure variability, how spread out the data points are. The range shows the difference between the highest and lowest values, while standard deviation measures how closely data points cluster around the mean. In finance, high standard deviation suggests volatility, while low indicates stability, helping us anticipate changes. While statistics analyze past events, probability predicts outcomes. Theoretical probability is based on known factors, like rolling a 6 on a die, 1 in 6. In contrast, empirical probability uses actual outcomes. For instance, if a basketball player makes 75 out of 100 free throws, there's a 75% chance they'll make the next one. This is valuable in fields like sports, finance, and medical research. Now, while statistics focus on analyzing data from past events, probability takes a different approach. Probability is all about predicting outcomes, asking questions like, what are the chances of something happening? Theoretical probability, which is calculated based on known factors, is the basis for simple events, like the probability of rolling a 6 on a fair die, which is 1 in 6. But real-life scenarios are often much more complex, and that's where empirical probability comes in. This type of probability is based on actual outcomes. For instance, if a basketball player makes 75 out of 100 free throws, we could estimate a 75% probability they'll make the next one. Empirical probability is useful where controlled predictions aren't possible, making it valuable in fields like sports, finance, and medical research. Independence in probability means the outcome of one event does not affect another. For instance, rolling a die twice shows that the first roll doesn't influence the second. This concept is vital in genetics, where genes are passed independently between generations. In contrast, dependent events occur when one event impacts the likelihood of another, such as drawing two cards from a deck without replacement, which alters the deck's composition. Understanding the difference between independent and dependent events is crucial for risk assessment and decision making in fields like biology, economics, and social sciences. Random variables are numerical outcomes from random processes, categorized as either discrete, e.g., the number of heads in coin flips, or continuous, e.g., temperature variations. They are essential in fields like engineering and physics for modeling complex systems and predicting behavior under uncertainty. By using random variables, statisticians and scientists can simulate real-world events and make informed predictions in areas such as weather forecasting and market trends. A concept that comes up a lot in statistics is the normal distribution, also known as the bell curve. In a normal distribution, data clusters around the mean, with fewer values at the extremes. This pattern often appears in biological and social phenomena, like human heights or IQ scores. Recognizing normal distributions allows analysts to apply statistical methods to predict future trends and identify anomalies. The bell curve is also the basis for many hypothesis testing procedures, making it foundational for evaluating scientific research and drawing reliable conclusions. Probability also plays a huge role in risk assessment across sectors like insurance, finance, and healthcare. Actuaries, those are the people who assess financial risks, use probability to estimate the likelihood of events like car accidents or health issues, enabling insurers to set premiums. In finance, probability models assess investment risks, helping investors balance potential returns with potential losses. Healthcare professionals also rely on probability to evaluate patient outcomes and create personalized treatment plans, balancing risks for individual patients and whole populations. With the rise of big data, the applications of statistics have surged. Predictive analytics uses historical data to forecast future events, influencing decisions from customer demand forecasting in companies to infrastructure planning by governments. As data collection increases, statistics has become a crucial skill for informed decision-making across various industries. Sampling involves selecting a subset of a population for analysis, allowing researchers to make predictions without surveying everyone. Large random samples yield valuable insights while saving time and resources. However, sampling errors can distort results, making it essential to ensure a representative sample for accurate conclusions. When we make predictions based on data, confidence intervals offer a range where we expect the true result to lie, allowing for a margin of error. For instance, a poll might show that 60% of people support a policy with a 3% margin of error, suggesting the true support lies between 57% and 63%. Alongside confidence intervals, hypothesis testing allows us to verify assumptions. By analyzing sample data, hypothesis testing helps validate ideas, from product popularity to medical trial outcomes, bringing objectivity to our decision-making. Advanced statistics and probability are also powering breakthroughs in machine learning and artificial intelligence. Machine learning models rely on statistical principles to recognize patterns in data, enabling them to predict trends, translate languages, and even diagnose medical conditions. As AI technology continues to evolve, understanding statistics will be essential not only for scientists, but for anyone who wants to stay ahead in the digital age. And as we continue to advance into the future, data analysis and probability will likely influence nearly every area of our lives, from AI-driven healthcare solutions to predictive algorithms in autonomous vehicles. Our ability to harness these tools responsibly will shape a future where data-driven insights deepen our understanding of the world. Thank you for joining me today on Next Level Gentlemen. In our next episode, we'll explore mathematics and technology, diving into how algorithms shape our digital experience and why mathematics is truly at the core of the tech we use every day. Until then, keep leveling up your knowledge and stay curious.